Hello friends, today we are going to study about fluid kinematics. The topic name is fluid kinematics. So first let me explain what does kinematics means. Kinematics is a branch of science which deals with only the effect of the force or load on the matter. Matter here is the fluid, that gas plus liquids. Okay, so basically this is a huge branch. Here we are going to study today only a particular topic named types of flows. So under the types of flows, first one under this is steady and unsteady flows. Okay, so first we are taking a section of a pipe, then we consider a cross section, say 1 So now according to steady flow, what will happen is at different instances of time, the fluid will have same properties. So as you can see at the same cross section, okay, at the same cross section, so at the same cross section, as the time passes by, say t1 or t2 or t3, somewhat like that, at the same location you will have same fluid properties. So this is steady flow. If these conditions are not satisfied, then the flow becomes unsteady. Now we will consider the next type, that is rotational and irrotational. Again we are considering another pipe section, okay, and somehow we have provided a torque so that the fluid particles are in rotational motion. So if each particle of the fluid are rotating in their own axis, then only the flow will become rotational, otherwise it's irrotational, sorry. And a very common property which is needed for a fluid to become rotational is viscosity. This is the very important property a fluid should acquire to have rotational flow. The third is uniform and non-uniform flow. What happens is, it is analogous to the first one. How? But it's also different. Let me show you how. Again we are taking a piece of pipe or a section of pipe. Here we are considering a lot of cross sections, say 1, 2, 3. So at a particular instant the velocity, just note, here we had all the properties, but here only the velocity of fluid remains same at every cross section. Mathematically we can write del v. So we can say partial derivative of velocity with respect to the space or the cross section at constant time is equals to 0. So this is uniform and non-uniform flow. Oh, and the last one, which you all might have heard, laminar and turbulent. So what laminar is? Lamina, it comes from lamina. So all the fluid will flow as if they are flowing in layers. There won't be any intermixing of the layers or the molecules, or no momentum exchange will be there within the layers. Okay, so that is laminar. A very important property which is needed is low velocity and high viscosity. Here, high velocity and low viscosity. And turbulent means, there won't be any layer formation, and the particles from one layer can get mixed to or diffused to the other layer, and the intermixing of the molecules and the momentum transfer within the layers can take place. And the very important property for this type of flow is high, oh, I forgot to write high velocity, sorry, and low viscosity. So here is the basic types of flows. As you have seen, 4 categories are there, and very asked ones in your semester exams, and I hope you're clear from this. And really sorry for the video and the audio, but I hope it won't be a barrier for you to get through the topic and the concept I have told you. Thank you for the day. Have a good night.